Okay, so we're doing this one. So if you chose to watch this from the beginning, you can. I'm going to skip these because we already did. And I'm going to start with, we already did this one. Well, I'll do this anyway. So here we have to do the distributive property, right? So negative 3 times n is negative 3m. So negative times a negative, so that's 15 greater or equal to 30. We can do minus 15 here, minus 15 here. And then 30 minus 15 is 15. 15 plus 15 and minus 15 equal adios. Negative 3m comes down. We now divide by negative 3 and divide by negative 3. Negative 3 divided by negative 3 is 1. 1 times m is just m. And I have to flip the sign because I'm dividing by a negative number. So 15 divided by negative 3 is negative 5. So if I graph this, here's negative 5. Be careful how you do your number line with negative numbers. It's backwards, I guess. Put a circle on top of negative 5. We shade. And we point the arrow this way because we want numbers that are less than negative 5. So check. Right? You can just use negative 5. 0 is not available because 0 is on that side. So I guess the next easiest number is negative 5. So negative 3. And wherever you see the m, I'm going to put a negative 5. So it becomes negative 5 minus 5 greater or equal to 30. I'm using the original equation, right? So negative 3 inside the parentheses, negative 5 minus 5 is negative 10. Greater or equal to 30. A negative times a negative is a positive, and 3 times 10 is 30. And is 30 greater or equal to 30? Yes, it is. So we know we're good. Why do we flip the inequality sign when dividing, multiplying both sides by numbers? So let's think about this inequality for a second. Let's multiply both sides by 3. Positive 3, by the way. Let me put a plus sign over here. So if I multiply both sides by 3, I get 15. And on this side, I get 27. Did anything change? No. Likewise, 3 is less than 7. Let me multiply both sides by positive 3 again. If I multiply 3 times 3, I get 9. And 7 times 3, I get 21. If that still holds true, it still holds true, right? So when multiplying by positive numbers, we don't have to do anything. Now, look what happens when we multiply by a negative number. So let's take 4 is greater than 5, which is true, right? Now let's multiply that by negative 1. And this by negative 1. Let's multiply both sides by negative 1. So negative 1 times 4 is negative 4. And greater, 5 times negative 1 is negative 5. Is negative 5 greater than, is negative 4 greater than negative 5? Yes, it is. So I'm doing something wrong here. Hang on a second. Oh, no. Well, I started wrong. 5 is greater than 4. Well, 4 is never greater than 5 to begin with. So let's start with 5 is greater than 4. And if I multiply both sides by negative 1, 5 times negative 1 is negative 5. And 4 times negative 1 is negative 4. Now look at your new inequality. Is negative 5 greater than negative 4? It is not. It is not true. So the only way to fix this is that we take the inequality and flip it the other way so that it becomes true. Because if we leave it alone, it's not going to be true. So we need to flip the sign in order to become true. That's why we flip the inequality the other way, because otherwise it won't work. So we need to make a little adjustment here when we multiply by a negative number, or even when we divide both sides by a negative number. We have to flip the sign, otherwise it won't be true. So here you had things where so this is greater than, right? This is less than. This is less than or equal. It can be two things. This could be greater than to an n, or equal, right? So that could be one. We can use other words, more than, smaller than. So these are, I guess, Greater than at least. This could be at most. And minimum, this could be another word we can use here, would be minimum. And this could be maximum. Another word here could be above, below. Well, those are all words that we can find, or there are probably more words that we can find in word problems that can indicate any of these inequalities. Okay. So, your weekly base salary is $150. You earn $20 for each cell phone that you sell. Write and solve an inequality that represents the number of cell phones you must sell to make at least $630. So you work and you make money, and every week they give you $150. Plus, they give you $20 for each cell phone that you sell. So let's say in this particular week you want to make at least 630. So at least means greater than or equal. You want to make at least 630 or more. So how is it that you're going to make that money? To make that money, you're going to sell cell phones and you're going to get $150. So per week, you get $20 per for each. And here is your your clues to what your variable is going to be your coefficient is going to be multiplied by. So cell phones, the number of cell phones is your variables. 20 times C, the number of cell phones, plus the $150 that you make, hopefully will be greater or equal to 630. So minus 150, minus 150. Take your calculator, and then you have 20C greater than, if you subtract this, it gets 0, 13 minus 5 is 8, and 5 minus 1 is 4. Divide both sides by 20, and C is going to be 24. So you need to C or greater. You need to sell at least 24 cell phones to make your goal of $630. So Chess Club is trying to raise $1,000, so you need a total of $1,000. They have already made 100. They sell raffle tickets for $5 each. Oh, here's our clue here, $5 each. How many more must they sell to make at least 1,000? How many more tickets? So I should have written tickets over here. How many more tickets must they sell to make at least 1,000? So tickets is our unknown. How many? I don't know. How much is each ticket? A ticket, it's $5. So here is our relationship. So I need to make $1,000, right? So they need to make greater than 1,000 or equal to 1,000. How are they going to make that money? Well, they're going to sell tickets. Each ticket, T, is $5. So there's our relationship. And it says that we already have $100. So how many tickets do I need to sell in order to get 1,000? So you can remember your story. Variable T times 5 plus 100 is greater or equal to 1,000. Inverse operation first would be minus 100 and then divided by 5. Minus 100, minus 100. Please, you can draw that line in the middle. So 1,000 minus 100 is 900. This goes adios and 5t comes down. Greater or equal to 900. Divide by 5, divide by 5. And t, 5. And t is going to be, I have no idea, 100 and, it's too early for this, 180. So you need to sell at least 180 tickets. Okay. An animal shelter has fixed weekly expenses of $750. So they have expenses, I don't know, pay for the doctors or pay for this and that. So it comes out to $750. And then each animal that they have in there is $6 a week for food and walk the dog and whatever expenses. related to just having the dog. So it's $6. So during the winter months, the weekly expenses are at most $900. Write to solve an inequality that represents the number of animals at the shelter for expenses to be at most $900 a week. So if your whole expenses, including the dogs, is at most 900, that means, okay, so it's not going to be greater than 900, it's going to be less or equal to 900. So of the $900, what makes up $900? Well, $750 for sure, because it's fixed. Every week they're gonna spend $750 no matter what on, like I said, expenses, electricity, this, paperwork, people who work there, wages, but those are fixed. It doesn't change, so it's always gonna be $750. Plus, their other expense is $6 per. Let's write D for dogs. So if on the winter time your expense is 900, how many dogs are in the shelter? That's pretty much what the question is asking. So do your story if you like. You have a variable D multiplied by C plus 750 less or equal to 900. We're going to do minus 750 first, and then we're going to divide everything by 6. So let's do that. Minus 750. Minus 750 on the other side. And we got 60 less or equal to 150. Divide by 6, divide by 6. And D is going to have, so how many dogs am I going to have? Excuse me. 150 divided by 6 is 25. So the number of dogs in that shelter is 225. Next one, you borrow $200 from a friend to help you pay for a laptop, computer. You pay your friend back $12 every week. You give him back $12. Write to solve an inequality to find when you will owe your friend less than 60. So this one is, so here's one relationship, another thing that you need to know, and this. So you want, the scenario is when will whatever's happening on this side be less than 60? So what is it that we're doing? Well, you're paying your friend, and every time you're paying your friend, it's being deducted from 200, right? It's being taken out of 200. So you have your $200 that you borrowed, and from that 200, you're gonna minus $12 every week. So, and if you're asking yourself, gee, I wonder how long it's going to take for me to owe him less than 60, this is the inequality you would have to solve. So, story, W times negative 12 plus 200 less than 60. Going back, we're going to do minus 200 first and then divide by negative 12. So, let's do that. Minus 200. Minus 200 on the other side. These two become 0. Negative 12W comes down, and 60 minus 200 is negative 140. Divide by negative 12, divide by negative 12. And we got to flip the sign the other way. W is going to be greater than, in order for you to owe him less than 60, it's going to take 11.666, or 11 with a 6, 11 with a, what do you call, 6 bar notation. So, because the question says, oh, it doesn't say how many weeks, but if we want to round it to weeks, it's going to be 12 weeks, okay? You're going to have to be greater than 12 weeks in order for you to be at a stage where you're going to be owing less than $60. Your plickers, we'll do it in class, and then I'm going to do now the questions that you're going to do in your whiteboards. Okay, so let's start with this one. So Miguel wants to have at least 500 in his account. Let me just go back here. I need my pen. Right, so you have to have at least 500. That tells me what my inequality is going to be. He already has 150. There's our constant. And he deposits 25 each week. So there is another relationship that we need to know. So at least means he wants to have at least 500. So it has to be greater than 500 or equal to 500. Let me write this a little smaller. I'll make this a little bigger. Okay. So at least 500 is this sign. So we know here $25 each week. So he's making $25 per week, 25 times W. And he already has saved, so that's plus 150. How many weeks will it take him to reach 500? So it's almost like the previous problem I just did on the video. So minus 150, minus 150. Cross out, 25W comes down, greater or equal to 350. Divide by 25, divide by 25. So that's going to be 4, 8, 12. W has to be greater or equal to 16. So he has to work 16 more weeks in order to reach his goal of 500. My doctor says, I guess I'm trying to lose weight, that I should consume no more, here's no more than 1,200 calories. I've already consumed 750 calories, and I'm going to home, and I'm hopping home to snack on some chocolate. Each chocolate, or mini chocolate, is 75 calories. So write and solve inequalities showing how many mini chocolates I can eat. Well, no more than 1,200 a day. That's not my maximum number of calories. So however many calories I eat has to be less or equal to 1,200. So is there there's each, here's my clue here. Well, another clue is each chocolate is 75 calories. So 75 times C for each chocolate, right? Every chocolate I eat is going to be 75 calories. And I already have eaten 750 calories. So that's going to leave me a lot of calories left for the rest of the day. So if you did your story, it's C times 775 plus 750. That gives you 1,200. The inverse operation is going to be subtracting 750 and then divide by 75. So let's do a minus. Let me change colors. Minus 750. Minus 750. Let's go again. Go out. 75C less than, and this is going to be 450. Divide by 75. Divide by 75 and see the number of chocolates I can eat, because I only have 450 calories left, and each chocolate is 75, so that's going to give me, I can eat 6 mini chocolates and still be under 1,200 calories. Caitlin makes $10 an hour. Okay, again, look, shade that. She receives a weekly bonus of 25. How many hours does she need to work this week to make more than 250? Well, more than 250 means greater than 250. Not equal, because she doesn't want to make equal. She wants to make more than 250, so it has to be a more sign. So how much does she make an hour? She makes $10 per hour. And she gets an extra $25 a week. So let's find out how many hours she has to work. H times 10 plus 25, 250, going backwards is the inverse operation, so minus 25 and divide by 10. Minus 25, 10H greater than 250, and then divide by 10, divide by 10, H is greater than 25. So she has to work, the number of hours that she has to work has to be greater than 25. Okay. Yucky cheese. We're back to yucky cheese. Caitlin, no. Sorry. Yucky cheese. Charges $50 flat fee for birthday rental. So just for you to rent the place is $50. Doesn't matter if no one shows up, 10 people show up, 20 people show up. So they charge you a $50 flat fee. So that's our constant. That's not going to change. And then $5.50 for each person that comes in. So Christina has at most $200. How many people can she invite? So at most means less or equal to 200. She can't spend more than that. So we know here's our relationship. It's $5.50, $5.50 per person, plus the $50 that we have to pay Yuck E. Cheese to rent the place. P times 550 plus 50, 200, less or equal to 200 minus 50, and then divided by 5.50. Use the times, divided by 5.50. So let's do that. Minus 50, change colors. Minus 50. 50 goes away, so I have $150, which makes sense because I have to subtract the fee, right? The $50 that I'm paying them just to rent the place. And then now I can calculate how many people I can invite. So divide by 550, divide by 550, and P is less or equal, so the number of people that Christina can invite is 50 divided by 5.50, which equals 27. If you look at the answer in the calculator, is 27.272727. Repeat it. So, can you invite 27.27 of a person? No. So the number of people that you can invite has to be less or equal to 27. So that's the maximum number that you can invite without going over your budget. Logan wants to take a taxi to visit his family. Pink cab taxi charges $1.75 flat rate, again, just for hopping into the car. They're going to charge you $1.75. That's how it works. And then he's going to charge you 65 cents per mile. He has at most $10. How many miles can she travel before she runs out of money? Hopefully, how many miles before she travels before she is out? By the time she runs out of money, hope she gets home. So at most means that she has $10 or less, right? She can't spend more because she doesn't have any more. The car is not, so here's our unknown. And an unknown is 6 miles, so it's, but I know the relationship is 65 cents per mile. And then plus I have to pay the taxi 1.75 just for sitting in there. Story. M times 0.65 plus 1.75 is 10. Going backwards is going to be minus 1.75 and then divided by 0.65. So let's do this. Minus, what is this? Minus 1.75. Minus 1.75. So minus, right? That's going to go bye-bye. 0.65. M is going to come down less than 8.25. So after you pay the taxi 175 just for sitting in there, now you can divide. So 8.25 divided by 0.65. And the number of miles that you can go is 12.69 more, but rounded it's going to be 12.69 miles. Just to be safe, well, how many miles? I guess it's talking. We can use decimals for miles. So number of miles, as long as it's less than 12.69 miles, you can use a taxi for that much. Okay, you better tell them to stop right away, otherwise you're going to be charged more. The gym has a maximum capacity of 750. Maximum means that it has to be less or equal to 750. You can't put more people in there just for safety precautions. The gym will probably get a fine if they hold more than the allowed amount of 750. So there are already 470 students in the gym. Write and solve an inequality to determine how many more students can enter the gym. Okay, so the number of students represented by x plus 472 has to be less or equal to 750. So this is a one-step equation. It's even easier, right? So minus 472, minus 472. This goes out, and x is less or equal to 750 minus 472 equals 278. So x, the number of students, has to be less than, 278. Okay. It's kind of weird to have that question. James has $29 and wants to have at least $50 to spend on his girlfriends for Valentine's Day. How much does James need to save each day if there are only 7 days until Valentine's Day? Okay, so he wants to have at least, so the amount of money that he wants to have is greater or equal to 50. Okay, so now what do we know? So there's 7 days to Valentine's. So the amount of money, and I'll use M for how much for money. Okay, so 7, he's gonna 7 times M. So every day he's gonna save a certain amount M, right? Every day, and he already has 29. So let's figure out how much he needs to save every single day. So let's subtract 29. So he already has 29, so that 50 minus 29 is 21. So now it makes sense, right? If he has $21 that he has to save and he has 7 days left, well, we're going to divide by 7, and M, the amount of money that he has to save every day, has to be greater or equal to at least $3 every day. Okay. Graph inequalities. Okay, so this one is nice and easy. Make a line, put an arrow on each side. 10, 11, just a couple of numbers on each side. 9 and 8. Shade or not shade, don't shade. M has to be a number less than 10, and numbers less than 10. On this side, you can always check. There's no way to get this wrong because you can always check. Is 9 less than 10? Is 8 less than 10? Pick a number, see if it holds true, and if it is, and it's on the same side where the arrow points, you're good. On this side, we have -3, so I'm going to put -3, -2, -1, -4, -5 for a circle. Shade, for sure. Now, -3 is greater than these numbers. This is what it says. -3 is greater than P. And -3 is greater than numbers on this side, on this side. So pick a number. Let's pick 1,000, million. Just to exaggerate, is -3 greater than this number? No. Where is this number? On the right or on the left side of the circle? On the right of the circle. So we don't want these numbers, therefore we aim it the other way. A is greater than -5. 5, -4, -6, especially with negative numbers. It says A is greater than -5. Especially with negative numbers, pick ridiculously large number just because it will be exaggerated and you'll really see it. So let me pick 1,000. Is 1,000 greater than -5? Yes, it is. Where's 1,000? Is it on the left side of that circle? On the right side? 1,000 is over here. So we want to point this way because all these numbers are greater than -5. -32, -31. Be careful how you do a number line when negatives. It's backwards. I'm going to shade. I'm going to do that much. And it says -32 is smaller than these numbers. Is it numbers on this side or numbers on this side? So again, let me pick a big number. A very large positive integer. Is -33 smaller than this number? Yes? Yes. Where is this number? On this side or on that side of the number line? Well, this number is somewhere on this side. So we point the arrow that way. Okay, so let me do this. This one's solved graph and check, so illustrated properly. Positive and negative and negative. Positive, negatives, and negative again. greater or equal to negative 20. You can make your story y times negative 10 minus 35 minus 20. So we're going to do plus 35 first and then divide it by negative 10. Plus 35, plus 35. These two cross out. Negative 20 and 35 is 15. Negative 10y comes out. We're going to divide by negative 10. Divide by negative 10. So when we divide by a negative number, we have to switch. And y is going to be 15 over 10, which we're going to change that to 3 over 2 or 1.5. So, or if you take the calculator, this becomes 3 over 2, or if you put it as a decimal, it could be 1.5, sorry, as a mixed number, or 1.5. So whichever one you think it's easier for you to do. So let me draw a number line. So the number is 1.5. Oh, negative, by the way. It has to be all negative. There's my negative, and then negative 1.5. This is negative 1. This is 0. Negative 2. Negative 3. We're going to put a circle, and it has to be shaded. So look at it. Let me just use this one. Negative 1.5. Why? These numbers are smaller than negative 1.5. And if you're smaller, so again, let me pick a ridiculous number. So let's pick up whatever this number is, a very large positive number. Is this sentence true? No, because this is not smaller than this. So this number is on this side of the row. So we don't want numbers on this side, we want the numbers on that side. So that's where we point. And then, just pause this for a second. Resuming. So I think I did that one already. And I have to do this one. So not too far from the end. It's a negative and a negative. It's a positive. 1/3 times 12 is just 4m. A negative times a negative is a positive again. And 1/3 of 15 is just 5. Plus 5. Less than 13. This one's pretty simple. Minus 5 here. Minus 5 here. And this one goes bye-bye. 13 minus 5 is 8. 4m comes down. Divide by 4. Divide by 4. M is less than 8. So let's graph that. So here's 8. Circle. 7, 9, and then we don't shade, and we want numbers that are less than 8, and numbers that are less than 8 are on that side. We have to check, and I don't know if I checked the previous one, so I'm going to check this one. So let's pick a number. Pick a very easy number. So less numbers that are 7, 6, 5. Any number that is on this side, you can pick whatever you want. I'm going to pick 0. Okay, so I'm going to pick 0 because it's available. Makes life easier. So if I go back to that equation, I'm going to give negative 1/3, and minus 12 times 0 minus 15 is less than 13. So let's see if that's true. So I'm not doing the distributive property. I'm going to, what do you call, now focus what's in the parentheses first. So it's negative 1/3. Let's leave that outside for a second. Negative 12 times 0 is just 0. So this goes, I can even erase it. And I get negative 15 less than 13. Negative times a negative is a positive, and 1/3 times 15 is just 5, and 5 is less than 13. So you know this inequality is true. So everything is correct. Is there anything else? So now I have no more than, really? So, no more than 12 cars. So again, we have, I like it this way. Where's my variables on that side, and my numbers always on the right side, I guess. So the number of cars that you have cannot be more than 12. So no, because no more than 12, it has to be less than 12. No more than 12, but it can still be 12, so it could be less or equal to 12. At least 12 candles. You should have at least 12 candles in case of a blackout. So again, candles and 12. So the number of candles that you're going to have at home has to be greater or equal to 12. Fewer than 12 cats. Oh. So again, C and 12. So if you have fewer than 12 cats, it means that you have less than 12. Not 12, but less than 12. More than 12 coins, and again, C, you have C and 12. To have more than 12 coins means that you have an amount that's greater than 12. Not equal to 12, but greater than 12. Did I make everything 12? Temperatures above 12 degrees Fahrenheit, so the temperature T is above, so it means that it's not 12, but it's greater than 12. And somebody has less than $10, so I guess money, M for money, and less than 10. Okay, not 10, but it has to be an amount that's less than 10, $9.99 and lower. Okay, and I think this is it. So, yeah, that's it. Pause.